So in the last video, I've gone beyond the point of no return. I'd cut the stem off of my yokes of my 1937 Scott Squirrel. What are we going to do about that? Well, we're going to do a lot of turning, a bit of screw threading, a lot of drilling. We fire up the laser and we have a disaster. Do we recover? Let's find out. Hello, welcome to Tweed's Garage, where in this video we're continuing work on the oleomatic forks off of my 1937 Scott. And in the previous video had to cut the stem off, where is it? This one, because it was in there at an angle, thought this was bent, turned out it was brazed in or silver soldered in on the wonk, badly on the wonk. So we needed to get around that problem. So we've cut it off, we've bored it out, faced it off and all that, but then we get into some convoluted fly cutting to work on the bottom, as it were. So let's go and have a look at that. So last job to do before I take the fork assembly out of my clamping jig here is, because I know it's all straight and true where I've bored this and faced this, I want to clean up the underside so that when the stem is pushed in, pushes perfectly true with the top face and the bore. So the easiest way to do that is machine it whilst it's still in this setup. So, but how do you get under here? Well, controversially, what we're going to do is fly cut it upside down. So I've turned the tool round up the other way, done it up nice and tight. We're only doing fine cuts on brass, so not too much of a strain. And then the only difference is we'll have to run the machine in reverse this way rather than this way, because now we've turned the tool up the other way. The cutting edges on the other face for the other direction. And I had to release the lower clamp here pushing this up because it would have got in the way. Before I'd done that, I put a indicator on this surface here and just measured the deflection. It was about 1 thou. When I released the clamp pressure, and I got all the clamps out of the way, then put a jacking screw underneath the yoke and just tweaked it, and it needed a minimal tweak. There's hardly any tension on that at all, just to bring it back up to 0 so that I can go in and face this underneath. What I have done is zeroed my y-axis that way so that I know my tool here isn't going to hit all my clamping arrangement underneath. Right, let's see how this goes. And there we go. Yes, it's turned out really well, and I measured it with the mic. It's nice and parallel, top and bottom. So yeah, that's perpendicular to that, and that's parallel to that. So next thing to do is to start work on the stem. So I put my steel stock in the lathe, and then proceeded to face it off and centre drill it. So that'll allow me to put a live centre in my tailstock and move the stock out of the chuck so I can work on the full length of the stem. Sounds a bit sordid. So now I proceed to start turning it down towards its finished dimensions. So I started with a spindle speed of 555, which sort of works pretty well for most materials, but it wasn't turning very nicely. It was creating stringy swarf, and a vibration was picking up on the shaft as I was turning it. And then normally, so what I've done was turn the speed down, and it's still done it, so then I turned the speed down again, and it didn't improve it got worse. So in sort of desperation we went the other way, so turned it up to 745, and it got better, and then ended up going up to 1000, and as you can see, that's turning up really nicely. For finishing cuts we might turn it up to 1340 when we're getting down to final size. But as you can see, it's producing a nice finish, and we're managing to sort of keep to our tolerances. I have fiddled around with the tailstock just to make sure it's sort of nice and parallel. So I'm not taking it down to final size. What I'm going to do first is drill the hole through the end I'm working on now as far as I can, then part the stem off from the stock down to its finished length. Then I can spin it round in the lathe and bore out the other end all the way through, so I've got my clearance hole, and then with that done I can come back in and start turning both ends of the stem down to finished size. So with the turning done as far as I wanted to do it, I now want to drill a hole in the end, so we'll stick on the live centre to hold it in position when I remove the live centre. Went in with a 14mm drill just to see what it would start drilling like, and it drills really nicely actually. You now find me here with a 20mm drill. It's yeah, a bit rough and ready. Got it from Amazon, but it's the only thing I could get next day. But it's drilling nicely, so we'll continue drilling the hole with this. So one thing I'll have to keep an eye on, I've discovered that I was using slide oil as I normally do on the fixed steady, but when this was getting hot it was starting to build up pressure against the rollers, causing friction in the oil, and it's only slide oil, and it was starting to burn up, get too hot. So instead I'm just sort of giving it a squirt of engine oil, motor oil that I've got in one of my other cans, which is designed more for running under load. So that's what we're doing here. We just finished the initial drilling just to see what it's drilling like. It's not drilling too bad, so it'll be a fairly lengthy process of, you know, drilling a bit, coming out, cleaning the swarf. Just keep going, just keep an eye on these rollers. Might have to back the rollers off a little bit, just take the tension out of it so it's not running too hot, and then hopefully we'll get down to the full depth, and if we keep cleaning it out we might be able to go a little bit further actually, and then that'll be the drilling done on this end. Bit of a diversion from the forks, but it was still a problem on the Scott. This is the reason I haven't put the gearbox back in. I had a bit of a problem with the clutch, and it was with the pressure plates. And as you can see, I mean, I've cleaned them up well, and since I've cleaned them up they've gone rusty again, where they've just been standing there in the garage. And you can see where over the years this has happened time and time again. You know, you look at the score marks on there, it looks like they've been run across a concrete floor a few times to try and clean them up, and you can see high spots, low spots. And when you actually put them together, I don't know if you can see that, you know, they're warped and bent all over the place, which doesn't make for a very good clutch operation on these Scotts, as far as I've sort of discovered. You want to get them as flat and parallel as possible, like most of the motorcycle clutches, but some are a bit more forgiving than others. If these are warped, it can make quite a disappointing clutch engagement. So I had a little think about it, and I haven't been able to find a source for these. Somebody put me in touch with like a Rudge website, but the trouble is the Rudge ones, although they have these internal tabs, I think they have 7 or they have 5, they have a different number of tabs on the inside, so that wouldn't work unless you could sort of change the middle, which is a bit, you know, a bit involved, trying to find one of those that would do the job. The other thing I saw, somebody had an adapted Norton clutch. I think what they'd done, they must have put the basket on. I don't know what they'd done about the internal tabs, because it would have been the other way around. I haven't looked at it actually, but I've got a Norton clutch kicking around. So, you know, that was possibly an option, but quite involved with a bit more engineering. So I thought, you know, you must be able to get some clutch plates machined out of steel stock, but these clutch plates are made from sort of a high carbon tough steel that doesn't distort very easily. You know, mild steel's no good because you can just bend it. So they're like a spring steel clutch plate that keep their shape. So you need something that's sort of strong, keeps its shape under load, side loadings, and will retain its shape under extreme conditions. And I had a look around, had a little think, and yeah, I came up with circular saw blades. So I had this big one kicking around, a couple of smaller ones kicking around, and I thought I might be able to get 3 clutch plates cut out from old circular saw blades. So this was going to be a proof of concept. Yeah, you've probably sort of seen him, probably heard that little ragamuffin Brian from Oak Swamp down in Southampton. He often mentioned a company, SW Asgood, where he got some laser cutting done. So I popped down there, went to see them, saw Stuart, and Stuart operates the laser cutter, and Richard there as well, one of the proprietors. I was having a little chat with them and asked whether he could cut clutch plates out of these saw blades. Now, you know, as you can see, they're crappy old saw blades. The other 2 were new ones but smaller, and I was expecting to be chased out with a broom and told to, you know, go and do something. But no, Stuart accepted the challenge, took the saw blades off of me, and then the lady there, sorry I didn't get her name, she said, oh, we'll phone you later on in the week when they're done. So this was done, I dropped these down on a Monday, and yeah, bit of a lazy bugger, getting out of bed Tuesday morning, early, it was before 9, they rung me up. She rung me up and said, oh, your clutch plates are ready, come and get them. So popped down there, and you can sort of see the result. But here's the other two, as you see, the old Parkside saw blades. There's a little tab there because these were cut out from smaller ones, but that doesn't affect the operation of them. So there's that one, that one, that one, and then you can see here, I've taped this one in just so you can see how fine the laser cut is, you know, and that is it, popped back in place. I've just taped it in just for a demonstration, just to show you. So we've done a trial cut on the bigger one first to see how the material would react to being laser cut, and Stuart said actually they cut really nice. He said the laser cutter liked working on these. And he says different metals react differently. He said, but these cut out, as you can see, really nicely. There is the tiniest sort of slag edge. I haven't even cleaned these up yet. These are as I got them. There is a tiny on one side where the lasers come through. Just occasionally, there's a tiny little burr on the edge. But they come out a lot better than expected. So what I'd done was provided, I didn't need to sort of send a CAD file down there. I just done a drawing on a piece of paper. I just gave the outside diameter as accurately as I could. The inside diameter, show the other side, the inside diameter from there to there. And then the internal diameter of the tabs, because they're circular as well. And then just the width for the tabs. As you can see, Stuart tapped that all into his computer on the machine there and saved it as a file. So there it is, ready to go. Brilliant. And then just sent it down to the machine once he'd lined the plates up. I'll show you how he does that.
I just put the dot on your part where it wants to be.
Oh yeah, I see the dot, yeah.
And then just bring it down and laser it from there.
Brilliant. Yeah, it's a machine, isn't it?
Yeah, it's only the kit.
Better have you in my video as well, Stuart. Just good man.
Yeah, no worries.
Press the button and 3 clutch plates cut out, and they go together really nicely. Now let's see if I can get that untaped for you. Hang on a minute. And this is them all together. Look at that. Flat as a pancake. Now they're slightly, these were the slightly smaller blades. This was this bigger sort of 9-inch blade. But as a proof of concept, this worked really well, and they fit in a lot better than the originals. The originals, I know they've had wear on them and that, but the actual, where you look at where they've been, I don't know whether they've been cut out manually or chopped out or punched out originally, but all the distances are all slightly different. So I sort of took an average when I'd done the drawing for Stuart, and as you see, these all fit in there. Lovely. So yeah, so that's proof of concept, but it'll probably go in there, and if it works they'll probably stay in there and I'll forget about it. But yeah, I was really pleased. I was quite chuffed with myself. I thought that was really good. So yeah, that was SW As Good down in Southampton. Splendid service, quick turnaround, and a reasonable price. So now these are done, I can pop this clutch back together, and the gearbox can go back in the bike. So what I will do is keep my eye out when I'm going around places, auto jumbles, car boots, that kind of thing, for bigger used saw blades that are nice and straight, and the bigger they are slightly thicker, and pick up a few more, and then I can just pop down to see Stuart and Richard, and he's got the file saved on his console on the laser cutter, and he can just punch that in and cut us out another 3. Yeah, pleased with that. I think we'll make a clock out of that for Mrs. Tweed. She'll love it. And there you go, there's the finished stem. So we had a bit of a heart-stopping moment on the thread cutting. I wasn't confident enough on the lever on the Angest gearbox, thread cutting gearbox. You've got to be really committed to, as soon as you feel it engage, you've got to push down and make sure it clicks in. I was a bit slow on the uptake on one go, and I didn't get it all the way engaged. The trouble is, if you don't get it all the way engaged, it sort of stepped slightly over. You might notice on the video, when it clicks in, you can see the tool sort of jump back a little bit before it starts its cut. But I noticed quite quickly on first two threads, I could see there was a problem. It was chewing up, so I just knocked the gearbox off and moved it back. It did sort of damage the top of the threads, but I wasn't too worried. I was more concerned about it sort of running all the way down and then damaging the thread completely. So all I done then, you saw me, is just turn down a little lead in shoulder at the beginning, just tidied up those damaged threads at the beginning, and then just sort of carried on cutting the threads at a slightly slower rate so we could keep tabs on it, and that went really nicely. So that's a nice fit, so that's that good job done. Put a little radius in the back of it, and then we continued to turn down the rest of the shaft. So the thread done, flipped it over the other way and just finished the push fit size to go into my lower yoke, and just put a taper transition between the two, you know, just to make it look nicer and make sure the shoulder was nice and sharp and flat, so that will retain nicely on the bottom of this. Now I was aiming for a bit oversized, so it was a push fit in, and it was, when I measured it on the lathe, although it wasn't hot, it was warm, it was a little bit bigger. It all looked okay. Now I've got it on the bench, everything's cooled down, it's actually spot on the dot, the same size as the hole, so it's sort of a tight fit. You can sort of start to wiggle it in. I haven't put it all the way in because I don't want to get jammed in there and then not be able to get it out. And what we're going to do is use some bearing retainer, high strength bearing retainer, liberal coating on this, liberal coating in this, and then put the two together, and once that's gone off, that won't be coming apart again because it's not exposed to high temperatures. It's just sitting there. It's just a fork stem. That's all it does. What we're going to do now is go to the garage and just press this in. Come on in. Jenkins, keep an eye on my cake. Bearing fit applied liberally. Let's line it up. Okay, here we go. Job done. So there we go, got the square against it, and it's lovely and square. So yeah, we're back to where it should be. So all I need to do is let that go off, slide on the new lower race, and I think that'll be, yeah, that's going on there nicely. Just tap that down, whereas before on the brass one it just dropped down. But what I'll do is I'll wait till the bearing fit as properly set before we start tapping it around, and all I've got to do then is sort of bore a hole in the steering damper bottom pad, back again, to be a push fit on the bottom of the stem there, and then spot it with a few spots on the old MIG welder just to hold it in place. And we're ready to assemble them back on the bike. I just need to spray the fork tubes, clean them up, sort the seals out, put them all together. But yeah, nice job done. Yeah, and now those line up with the holes down below, whereas before, you know, you had to tilt this sort of this way to get it anywhere near. So I'll call that a result. So there you go. Hope you liked the video. If you did, give us a little like and hit subscribe. And oh, there's a hype button. Haven't got a clue what it does, but if you see it, poke it. Right, I'm going to eat my cake and I'll see you next time. What's that, Jenkins? No, it wasn't your cake. I was just keeping you motivated. Yeah, carry on. See you later. Cut the stem off my 1927 Scott. Point of no return. I cut my stem. Now, as you saw last time, we'd bored out the holes of the milling machine. Hello, welcome to Tweed's video. We're in this video.